The question given is, if cos theta plus cos square theta is 1, you have to prove that sine raised to 12 theta plus 3 sine raised to 10 theta plus 3 sine raised to 8 theta plus 6 sine raised to 6 theta plus 2 sine raised to 4 theta plus 2 sine square theta minus 2. This all total is equal to 1, you have to prove. Okay. Now let us take the solution. Now what is given? This is given. So let us write that first. Cos theta plus cos square theta is equal to 1. This is given. So let us take cos square to this side. It becomes cos theta is equal to 1 minus cos square theta. 1 minus cos square theta is the identity. You know it is equal to sine square theta. So cos theta is sine square theta. Now you see, we want different powers of sine. 12, 10, 8, 6. So let us try. Take square of this expression. When you take cos square, what will become? Cos square theta will be sine raised to 4 theta. Again take the square of this. Cos raised to 3 theta is equal to cos raised to 6 theta. Take the fourth power. Cos raised to 6 theta is equal to sine raised to 12 theta. Okay. We are taking only up to 12 because we need only sine 12. Now, let's write this expression. Sine raised to 12 can be written as sine raised to 4 into 3. 4 3s are 12. And sine raised to 10 theta, 3 into sine raised to 8 theta plus sine raised to sine square theta raised to 3. 2 3s are 6. And 2 sine square theta raised to 2. That is 2 2s are 4. And 2 sine square theta minus 2. Okay. Now, what is sine square theta? We know it is sine square theta is equal to cos theta. So if you put that, so let us write this much. Sine raised to 4 theta whole raised to 3. 10 I break it down as 8 and 2. 8 plus 2 is 10. So 3 sine raised to 8 theta sine raised to 2 theta plus 8 we break it as 4 4. Sine raised to 4 theta plus sine raised to 4 theta plus sine square theta raised to 3 plus now sine square theta square plus 2 sine square theta minus 2. This one sine raised to 4 theta raised to 3. 3 into 8 I am writing it as 4 2s are 8. So sine raised to 4 theta raised to 2. Sine square theta 3 sine raised to 4 theta and sine 4 I am writing as sine square theta raised to 2. Sine 2 2s are 4. And sine square theta raised to 3 and 2 sine square theta raised to 2 plus 2 sine square theta minus 2. Next step. Sine raised to 4 theta. Sine raised to 4 theta is cos square theta. So I'm going to replace this with cos square theta. So cos square theta raised to 3 plus again sine 4 is cos square. So cos square theta raised to 2. Sine square I'm keeping it as it is. Again sine raised to 4 theta is cos square theta. Again write it as cos square theta. And sine square theta raised to 2 plus sine square theta raised to 3 plus sine square theta. Sine square theta is cos square theta. So sine square is cos and cos square is cos square theta. So 2 cos square theta plus 2 sine square theta minus 2. Now if you see this, a raised to 3 plus 3a square b plus 3ab square plus b raised to 3. It is taking a form. So it is a raised to 3 plus 3a square b plus 3ab square plus b raised to 3 is a plus b whole cube. It is matching an identity here. So this is your a and this is your b. So sine square theta is a and cos square theta is a and sine square theta is b. So it is a square a cube plus 3a square plus into b plus 3a b square plus b raised to 3 minus this plus this. So now let us what it happens. So this is in this form, therefore it becomes this is your a and this is your b. So it becomes sine square theta plus cos square theta plus sine square theta raised to 3 And from here, you take out 2 common, 2 bracket, sin, cos square theta plus sin square theta. Sin square theta plus cos square theta is 1. So this becomes 1 raised to 3 plus 2 into 1 minus 2. So 1 raised to 3 is 1. 1 plus 2 minus 2. 1 plus 2 minus 2, which is equal to 1. So our expression is this. Clear? Hope you understood.